Good afternoon, ladies and gentlemen. I am pleased that you're interested in my poster on the topic Mixed-Age Chemistry Classes, Conception and Realization of Integrate Experimentation Sets, and welcome you to this poster presentation. In that presentation, I would like to introduce you to the topic and the content of the poster in more detail. But before I start with the actual presentation, I would like to introduce myself briefly. My name is Marcel and I'm a research assistant in the Chemistry Education department. Born in Saalfeld, where I also completed my A-levels, I studied grammar school teaching profession for the subjects biology and chemistry at the Friedrich Schiller University in Jena. During this time, I worked both as a student assistant in the Chemistry Education department and as a substitute teacher at the Montessori school in Jena. In 2017, I completed my studies with the first state examination and have been working as a research assistant in the Chemistry Education department since then. My tasks include, for example, teaching of future chemistry teachers, supervising final theses, and coordinating our chemistry student laboratory in Jena. In my doctorate, I'm working on the topic of learning to teach laboratories as places for professionalization of future chemistry teachers. The structure of the presentation is based on the structure of the poster. First, I would like to introduce you to some thematic aspects of mixed-age teaching. Afterwards, I will present the research focus of this work, addressing both the central questions and the methodological approach. In the context of this process, an experimentation set on the topic of acids and bases was developed, which was used in mixed-age teaching. I would like to present this to you in the third point. Finally, the presentation will summarize the central results on this work. We will now start with the short theoretical input on mixed-age teaching. In the course of the restructuring of the German school landscape over the past 15 years, concepts have been established which, on the one hand, implement a changed approach to the heterogeneity of the student body, and which claim to teach independent and more complex learning and work. In addition, they also strengthen the practice of internal differentiation to a great extent and thus allowed for more intensive support of the individual development of students. A model in which all these pedagogical elements are integrated is represented, for example, by the approach of mixed-age teaching, which is already implemented mainly in the primary level of the German education system. However, this pedagogical approach is not new and has been discussed constantly over the past decades, as this quote from Hentig shows, for example. The differences between people are something natural, and that the affirmation of difference benefits each of us is experienced in mixed groups. The new school will, wherever it can, bring together children of different ages, talents, cultural interests, and religions, on the basis not of the 1-year group, but of 3- to 4-year groups. In the years that followed, the definition has steadily expanded. In 2003, for example, Laging referred to age mixing in his remarks as a combination of several years into one school class or fixed learning group. Modern definitions of this conceptualization resulted from all these considerations. These understand mixed-age teaching to be an alternative form of school organization in which students are not grouped into classes by year, but rather different age groups are integrated into one class. That latter definition should serve us as a clarification of terms for this presentation. In the context of mixed-age teaching, three different organizational forms can be differentiated, according to Wienman. The so-called multi-grade classrooms are basically understood as the teaching of different grades together, in contrast to the classical single-grade classrooms. According to Kuhl et al., the establishment of these classrooms is essentially based on organizational considerations. Multi-age classrooms, on the other hand, are set up for pedagogical reasons, with a view to promoting individualized learning processes. They summarize the learning of children of different ages. The highest form of these forms, however, are the so-called non-graded classrooms. The structure of such schools is not based on the age of children, but on their individual performance levels. Flexible groupings in the sense of performance homogeneous learning groups are created. At this point, however, it must be pointed out that these terms are usually not used in a clear-cut manner, and they cannot be regarded as independent of each other. An example of an educational concept in which mixed-age learning plays a central role is the reform pedagogy according to Maria Montessori, which focuses on the child itself. This pedagogical approach can be summed up in probably the most famous of her quotes: "Help me do it myself." She looks at the child from birth to adulthood. In doing so, she assumes that children out of a natural drive can and want to learn on their own. Thus, self-determination in the learning process, for example with regard to time, pace and content, takes on an important role. In this context, Montessori sees the child as the master builder of the future human being. Montessori education is a complex construct, which can, however, be subsumed into essential elements. These include, for example, the role of the new teachers, the polarization of attention, cosmic education, the prepared learning environment, or the sensitive phases of a child postulated by it. The environment of the mixed-age learning group represents also one of the core elements of Maria Montessori's reform pedagogy. Here, students of three grades learn together. The three-age mixture typical is based on the principle of naturalness it describes. Montessori sees the age mix in the school as a reference to the child's natural habitat, but the age-rich grouping as a departure from it. This is also made clear by her quotation: "Even if we had over 1,000 children and a school palace, I would think it is always advisable to have children of an age difference of 3 years together. This age difference and this mixture of different developmental stages are a basis for self-education." Now I would like to move into the second presentation section, which deals with the research interest as well as the study design. Before I go into that in more detail, I would like to tell you about the actual reason for this work. For this purpose, it is important to know that the school career of a student in Germany can be divided into 3 areas. A student's school career usually starts in the age of 6. From the age of 6 to 10, students are taught at primary schools. Then they move on to a secondary school form and thus to lower secondary school and the secondary level 1. Students who want to go to university and need their A levels to do so must also attend upper secondary school in the secondary level too. Students are traditionally taught in age homogeneous classes in each of these 3 school levels. This system is also compulsory for the federal state of Thuringia. At the Montessori school Jena, a Thuringian community school with about 700 students, multi-age classes will be increasingly integrated into science classes starting in the 2017-18 school year, in the form of the 3-year mix based on Maria Montessori's reform pedagogy. In this context, the typical class groups were dissolved, thus creating a new school structure. Starting in the junior grades, the students go through 2 middle grades and finally reach the senior grades, where they can take their A levels. What is special now is that the students are no longer taught in age homogeneous classes, but in mixed age classes in the respective levels. This restructuring process began when I was still working as a substitute teacher at this school. My mentor in chemistry asked me at that time if I would be interested in developing cross-grade topics and materials for chemistry classes. And so the idea for the present work was born. So the work supported this process in chemistry class with regard to the following aspects. A first part dealt with the presentation of basic construction criteria for learning and experimentation sets in the context of age heterogeneous learning. So that first central question arose from this. What design criteria must learning and experimentation sets meet in order to be used in the context of mixed age learning? Based on this criteria catalogue, derived from theory and supplemented by statements of science teachers, such a set was developed as an example and placed in the focus of further investigations. The central goal of the subsequent testing and evaluation of this set on the topic of acids and bases by students between the ages of 13 and 16 was to examine the suitability of this material regarding its use for promoting and optimizing chemical learning processes in the context of mixed-age teaching in lower secondary school. In summary, the second research question asked, are the materials developed appropriate for age heterogeneous learning? Basically, the format of this work followed the design-based research approach, according to which a practice-oriented problem or question is answered in a theory-guided way. For this purpose, it was necessary to establish interdisciplinary references between educational and scientific fields in the work. Due to the explorative character of the questions raised, the approach of this work can be assigned to the tradition of qualitative research methodology. In this context, a process was realized that comprised a total of 4 central phases, alternating between theoretical curricular and qualitative work steps. The first step represents the theoretical basis. In particular, this means the literature-based research on theories of didactics and educational science. From this step, the first design criteria for the design work could already be derived and the qualitative research instrument developed. In a second step, a first qualitative work followed. This means the acquisition of criteria for the construction of age heterogeneous experimentation sets by interviewing science teachers through the use of guided short interviews. These 2 steps formed the groundwork for the actual curricular work, which focused on conception and realization of the experimental set, based on curricular textbooks and already existing experiments. Finally, another step of qualitative work followed. The focus here was on the testing and evaluation of the experimental set by students between the ages of 13 and 16. The testing took place in age-homogeneous groups in order to be able to check the age-related suitability in particular. The evaluation was also carried out with help of guideline-based short interviews. However, this is not the end of the process. Based on the insights gained, conclusions can be drawn which in turn enable the curricular work to set to be optimized. This brings us to the third part of this presentation, in which I would like to briefly introduce the experimentation set that I've developed. Conceptually, it should be first mentioned that the learners are granted freedom so that they can actively shape their learning process. This includes, for example, the free choice of the social form, as well as the determination of the sequence in which the subject areas or individual modules are worked on. The exemplarily developed subject area is divided into a total of 4 modules, each with a thematic focus. Module number 1 is a theory module in which basic knowledge and fundamentals are to be laid. Module number 2 deals with the topic of assets and bases in our everyday life and thus establishes a direct link to the student's living environment. Properties and chemical reactions of acids and bases are thematized in the third module. In order to expand the content dealt with so far from a purely inorganic point of view to include organic chemistry, a fourth module was designed, which addresses carboxylic acids. That remaining 3 modules consist exclusively of experiments. Each module is subdivided into individual stations, which are either of a theoretical or experimental nature. The curriculum for chemistry teaching in Thuringia forms the basis for the content to be worked on in the stations. This illustration shows you the materials of the set in a clear way. As you can see, a separate folder has been created for each module, which contains the respective documents, for example, experiment instructions. In addition, each module has its own color, which is also reflected in the corresponding booklets. The smaller red and blue boxes contain all the materials needed, for example, equipment and chemicals, to carry out the experiments in the set. The boxes are labeled with the title of the respective station in the corresponding module color. All materials are stored in a space-saving and practical way in 2 large carrying boxes. This second illustration shows you an example of the materials of a selected station, here on the topic of pH value and indicators. In this experiment, common substances from the household, for example lemon juice, are to be examined for their pH value with the help of red cabbage juice and universal indicator. This experiment serves as a classical introduction to the topic of acids and bases. As I just mentioned, the station box contains all the materials needed for the experiment, for example test tubes, pipettes, or the solutions to be examined. The work instructions for the experiments generally have a bidifferentiated character, which is applied in the form of a traffic light system, red, yellow, green, for the individual requirement levels. The instructions are basically written on the requirement level number 3, in red. Consequently, the students are required to deal with this level first. In case of difficulties, the learners can use a tablet or a smartphone to scan the QR codes printed on the second page of the instructions. After this process, a PDF file is opened on the corresponding device, which contains differentiated instructions depending on the level of difficulty, with more concrete instructions, hints, and pictographic experiment setups. In this way, Students should be able to reflect on their own level of knowledge and ability and choose differentiated instructions according to their individual learning level. After an experiment has been carried out, it is finally evaluated, usually in form of a worksheet or a report, in a task or content-oriented manner. For this purpose, the learners are also provided with assistance in the form of literature references for research or in the form of learning videos, which are also QR-coded and can be called up as needed. On the one hand, this principle is intended to ensure that the competency goals anchored in the curriculum are achieved. On the other hand, the students should be able to choose the depth of processing and contribute their own ideas and approaches to solutions. After giving you a little thematic input and introducing the study design and the experimental set as well, I would now like to conclude with the central results of that work. Based on partial transcripts from the guided short interviews with the teachers, a comparison could be made with the theoretically determined design criteria. Synthesizing these results, 3 central fields with a total of 9 criteria were identified. First of all, subject-related criteria could be collected. When developing learning sets in the context of mixed-age learning, care should be taken to ensure that the content to be considered is chosen appropriately for all ages involved. The material also enables learners to gain knowledge in terms of different competences. A second dimension, dedicated aspects of material design should be considered, such as promotion of independent work, structuring as help and orientation, space for own interests and questions, the opportunity following one's own learning path, as well as a stimulating design. Due to the cooperation of students of different ages, social points should also be taken into consideration. Thus, the concept should allow the free choice, of social form, as well as actively stimulate cooperation between learners of different ages. On the one hand, these factors represented the starting point for the curricular development work. On the other hand, they also served as the basis for the development of the intervention modes for the evaluation interviews with the selected students. The overall transcripts of the short interviews that were also used, which were produced from these discussions, allow us to conclude that the material developed is suitable for use in inter-year science lessons. So the final question is, are the materials developed appropriate for age heterogeneous learning? Yes. Superficially, with regard to structural and material aspects, the results give reason to believe that the present system can be retained and, if necessary, applied to further thematic sets. But in summary, however, it must be also stated that a primary optimization of the tasks with regard to a higher level of challenge for older learners appears to be necessary. Furthermore, the production of more test-specific learning videos should be increasingly realized. On the basis of these results, it is conceivable to support the further development of teaching in the subject chemistry at the Montessori school in Jena by the conception of further sets which can be justified spirited curricula or project-orientated. Based on the results presented, as well as the constantly progressing pedagogical developments in the school context, it is evident that one of the oldest forms of learning, namely mixed-age learning, should still enjoy great importance today. In this context, I would like to conclude with a quote from Jenser, which summarized this insight well 30 years ago. The image of the teaching adult surrounded by children is a timeless image. For thousands of years, teaching could not have been imagined any other way than face to face, eye to eye. In essence, we are dealing with the timeless uniform of human teaching and learning. Finally, on this slide, I've summarized for you all the relevant sources on the content presented here. So this brings us to the end of this presentation. I would like to take this opportunity to thank you once again for your interest in this topic, but also for your attention. I am of course at your disposal for any questions, discussions, or suggestions. With that, I bid you farewell. Stay healthy and have a pleasant time at this conference. Goodbye and best regards from Germany.